Okay guys, today we are going to go over the study guide for comparing bits and pieces so that you're prepared for your unit test on Thursday. So, the first thing that we need to make sure you can do is that you understand fractions, percents, and ratios as a way to represent part-to-whole relationships. The sample problem that goes with that is this. There are 30 marbles in a bag, 24 marbles are black, the rest are white. So we are comparing the part of the bag that is black to the marbles in the whole bag. So we are making a part-to-whole comparison. We are writing that as a fraction. We know that there are 60 marbles in the whole bag. And we know the part that we are talking about is the black marbles, and that is 24 marbles. So 24/60ths is the percentage, or is the fraction of the marbles that are black. If you have a calculator, you can quickly change that fraction into a percent by dividing. You want to take 24 and divide by 60. And that's going to get you this 4/10. I know that 4/10 is a benchmark fraction. 4/10 is 40%. So I'm going to write that down here just in case, and then I will show you how to find it if you don't have a calculator. For example, we've been working in class to either scale up or scale down. Oh my goodness.
Daenerys Livingston, please report to the main office. Daenerys Livingston, please report to the main office.
Sorry for the interruptions, but we are going to actually scale this fraction down until we get to a benchmark fraction that we can find our percentage from. For example, I'm going to scale 24 out of 60. I'm going to take that fraction and I'm going to cut it in half. If I have 30 marbles in the whole bag, I would have 12 black marbles. All I did was cut the bottom number in half and the top number in half. I don't recognize this as a benchmark fraction, so I'm going to keep going. I'm going to scale down to 10. So what I'm doing is I'm decreasing this by a factor of 3, dividing 30 by 3, that gives me 10. 12 divided by 3 gives me 4. And there's that same 4/10 that we saw when we divided. 4/10, I know that 4/10 is the same as 41/100 because I'm scaling up by a factor of 10. 41/100 is 40%, just like we found with our calculator. The second one says, what fraction of the marbles are white? So again, we're comparing part to whole. We still have 60 marbles in the whole bag, but now the rest of the marbles are white. So we have 24 black and 36 white marbles makes 60 marbles in all. So 24 plus 36 makes 60. And again, I'm going to scale down. I'm going to follow the same steps that I did with the black marbles. I'm going to cut the fraction in half first. I'm going to start, if I know that 36 out of 60, I know that I can cut that in half, and I know that that is 18 out of 30. Then I'm going to scale down by a factor of 3. 30 divided by 3 is 10. 18 divided by 3 is 6. Again, I have a benchmark fraction here. I have 6/10. I know 6/10 is 60 out of 100, the equivalent. 60 out of 100 gives me a percentage of 60%. And again, if you had a calculator and you wanted to use it to turn the fraction into a percent, you could do 36 divided by 60, and that would give you 6/10. You could scale up to 60/100. 60/100 is 60%. So if you can do that, then you are in good shape for that area of your quiz. The next set says I can identify equivalent fractions, decimals, and percentages. So this is pretty easy. It asks which fraction, decimal, or percent is not equivalent to the others. Explain why it's not equivalent. So this is 10%. 10% is the same as 10 out of 100. This is 1/10. I know that 1 out of 10 is equivalent to 10 out of 100, so they're both the same thing. Here's 10 out of 100, 10 out of 100. They're both equivalent. This is 1/100th. So these two are equivalent. The third one is not. These are both 10/100ths. This is only 1/100th. So this one is the one that is not equivalent. And we just did that by scaling up, or we scaled it up to 1/100th. You could have also used percentages to compare. This one is clearly 10%. 1 out of 10 is also 10%. This 1/100th is 1%. So these two are the same, and again, this one is different. 1 out of 100th is 1%. So if you can do that, then you've got your equivalent fractions, decimals, and percents checked off. The next question says, I understand place value and can order decimals with digits in the thousandths place. So, again, the strategy in class is to write the numbers, to stack them up. So we have the ones place clearly marked, the tenths place clearly marked, then we have hundredths. And if it goes further, we have thousandths. So we've got ones place, tenths, hundredths, and thousandths. So I'm just going to rewrite these numbers so that they're stacked up so I can see their place value parts clearly. So I've got -4. I've got -34 hundredths. I've got -40 thousandths, or 4 hundredths. We could actually get rid of that 0. We don't need it. It doesn't change our number at all. I've got -4 tenths. And then at the very last one, I've got -34 thousandths. All right, so let's go ahead and think about our negative number line. We know that as we move away from the 0 on our number line, our numbers are decreasing. So that the smallest numbers are going to be down this way, and the largest numbers are going to be the ones that are closest to 0. So our smallest numbers will be far away from 0, and our largest numbers will be closest to 0. So as we move away from the 0, what is the first number that we will run into? Will it be $4? Will it be 34 cents? Will it be 4 cents? Will it be 40 cents? Or will it be 3 cents? We actually don't even need this 4 either, because it's just distinguishing between, it's a little bit more than 3 cents, but not quite 4. So the first thing that we will run into will be 3 cents. So our largest number is going to be -3 cents. And we'll put the 4 on there because that's the number that we used. All right, that one's done. Then as we move along our number line, the next number we will see would be -4 cents. Oops, I'll write that 0 in there. That makes a difference. So we got those. We got this one's done, and this one's done. The next thing we would run into, would we run into 34 cents or 40 cents first as we're moving along our number line? We would run into negative 0.34 and then negative 0.40. And then further along down our number line, we would run into negative 4.0. So from the smallest to the largest, this is our order: negative 4.0, negative 40, negative 34, negative 4, and negative 3 cents, negative 4 hundredths, and negative 34 thousandths. So you guys can pause this video whenever you want in order to copy or listen again or rehear any of the things that I'm saying in order to help you study. Alrighty, moving on, we're going to flip to the back. The back says I can understand fraction equivalence and can explain whether or not two fractions are equivalent. Again, I'm going to use my scaling up strategy just to see if these two are equivalent. I can scale up 2/3 into 1/18. I know I can scale up by a factor of 6 because 3 times 6 makes 18. So I'm going to multiply my numerator by 6. 2 times 6 is 12. So these are equivalent. I can tell that 2/3 and 12/18 are the same. They are both equal. The next one, again, I'm going to scale up my 1/4 so that I can have a denominator of 20. I know that I have to scale up by a factor of 5 because 4 times 5 is 20 and 1 times 5 is 5. So I can scale up and get exactly the same fraction, so I know that those are both equivalent. The next one, I have an improper fraction. I have 12/10 or 1 1/5. I'm going to change this fraction into a mixed number. I know that 10 goes into 12 one time with 2/10 left over. I know that 2/10 is the same as 1/5. So I have 1 whole and 1/5, which is the same as 1 1/5. So that is also equivalent. So we have 1, 2, 3 equivalent fractions. And we did that by just scaling up. So we can check that off of our list. The next one talks about unit rate. I can calculate unit rate and use it to generate equivalent ratios. And again, a ratio is a part-to-whole comparison, just like a fraction. Ratios can also be part-to-part comparisons. In this case, we are comparing scoops of lemonade mix compared to the cups of water. So we're talking about the mix compared to the water. So in this ratio, we need 3 scoops of mix and we need 15 cups of water. The first question asks about the unit rate. So the ratio of mix to water is 3 to 15. This is the answer for the first part. What is this as a unit rate? Meaning 1 scoop of mix for how much scoops of water? So if we had 1 scoop of mix, how much water would we need? So again, for this problem, we're going to use a scaling down strategy. I'm going to start with 3 and I need to scale down to 1. I can do that by dividing by 3. 3 divided by 3 gives me 1. 15 divided by 3 gives me 5. So I know that the unit rate is 1 to 5. 1 scoop of mix for 5 cups of water. Suppose you want to make 45 cups of lemonade. How many scoops of mix do you need? So again, we've got our mix to water ratio. I know that I need 3 scoops of mix for 15 cups of water. and I need to scale up to 45.